We mentioned DAS 1.0 was all coax and DAS 2.0 is a mix of coax and fiber. But why use coax for DAS in the first place? Main reason is coax is built for sending and receiving RF signal. Also, most commonly used coax in DAS is half-inch diameter. In this picture from Wikipedia, you can see a cross-section of coaxial cable. You can see the center conductor wrapped around by insulator, right? The dielectric insulator, which has a metal shield around it. And this is the metal shield. And finally, whose assembly is wrapped around by a plastic jacket. All of these has a common axis and hence the name coaxial cable. Have you seen this coax before? Most likely you have. If you have cable TV, you have seen coax in your house. The black cable that is connected to the router or your set-top box is usually coax. Coax in typical DAS is a little bigger than your cable TV coax. Most of them are blue and half-inch in diameter, as I mentioned before. Unfortunately, coax-based system has limitation. It's very lossy. That means signal loses strength significantly with length. Signal quality also suffers. Signal quality is commonly known as signal to noise ratio or SNR. For good cell signal, we need both strength and quality of the signal. So in summary, coax is essential for transporting signal, but it's not good for long distance transport of that signal. By long distance, I mean 100 feet, 50 feet or longer. So what's the solution? Enters fiber optics to help. Fiber cable can transmit signal over a long distance with minimum signal loss. Fiber is an attractive transport medium in DAS, but there is something interesting about fiber optics cable. Core conductor of fiber optics is glass, not copper, like coaxial cable. See the glass core in the red square? It's sometimes hard to grasp that the materials we drink water from can also be used for sending and receiving signal. DAS uses fiber to transport signal to a long distance. And by long distance, I mean maybe a few thousands of feet with minimal loss. You could not use coaxial cable to pass RF over that distance. This trick works well, real well for DAS when multiple buildings are involved in a commercial campus. Remember that most commonly used fiber in DAS is single mode fiber as opposed to multi-mode fiber. So by now you may be getting a sense that with a combination of coaxial cable and fiber optics, we can cover a much larger area. But how can we convert RF signal to optical and back to RF again? We need RF because our phones can only process RF signal. So engineers came up with devices that can convert signal from RF to optical or vice versa. These are essentially a type of converter. For DAS systems, different manufacturers have different names for these converter boxes. They do have quite a few other functions besides converting, such as managing gain or power level of signals. But to keep things simple for this course, we'll just give them this generic title of converter.